the law of sines allowed us to solve for any triangle that was angle, angle, side, or angle, side, angle, or side, side, angle, right? So technically we still have two other cases that could happen. So now we're going to learn to solve a triangle when two sides and the included angle are known. What does it mean to be an included angle? You guys remember? It's in between, right? So this would be side, angle, side, which we have not seen yet. Or when all three sides are known, which is side, side, side. So we're going to use the law of cosines to do this. The law of cosines looks uglier than the law of sines, but it's pretty straightforward to use. There's obviously like three different versions relative to what you're looking at here, but I think you guys kind of get the picture. A squared equals, so you'll notice like if this is little a squared equals, you're looking at the cosine of a, like that angle, and so on, and then the other letters show up too. I'll read them all. So this is the formula we're going to use today. So this is calculator heavy, and I'll try and show you with the calculator because it turns out rounding really matters like a lot, and I'll show you what I mean here with example 1. So the go format might be a little touchy. I think I have it fixed now that second hour's gone through it, but we'll see. So example 1, we want to solve a triangle for the side angle side case. So this case, we want to solve triangle ABC when A is equal to 11, C is equal to 14, and then our angle B is equal to 34 degrees. So if you want to draw the picture, it's not required, but if you want to, it would look something like this, where you have a C, B, and A, and then we know little c is 14, little a is 11, and then little b. Remember, always like across from your angle B is the side little b, and so on. So this is what we know. So clearly, side, angle, side. So our steps for solving, excuse me, I'm dying. Our steps for solving here. Our first step is that you're going to use the law of cosines to find b, little b. So if you were given like the big C, you'd find little c. If you were given big A, you'd find little a, and so on. It's going to be your first step here. So if I'm finding b, we're going to use this second equation on our table. So we're going to use the b squared equals a squared plus c squared minus 2ac times the cosine of b. So let's plug in for what we know. We'll have b squared equals 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34 degrees. So here's where I would just type this all into your calculator. Trust that your calculator can do order of operations because the good ones can. I don't know about your phone calculators. I don't know why people still use those. Minus 2 times 11 times 14 times cosine of 34. Make sure you're in degrees, I guess, before I do this. I am. I hit enter, and I get 61.656, all this stuff. So here's where, yeah, the book then, so this is where like I'm a little distrustful here. The book says, okay, b squared is approximately, they say 61.7. And so, well, so they just rounded, and that's fine. They rounded to the first decimal place, but like depending on when you round, I feel like you're going to get a different answer because then they said B was 7.85. And so I would use like second answer, and 7.85 is fine. But then what I had done is I rounded, the first time I did this, I rounded to 7.9, and that was bad to do apparently. And I'll show you what I mean here. So I'm going to be as flexible as I can about rounding, but I guess try and use second answer as many times as possible until the very end and then round to the first decimal place. And I'll show you what I mean for this next step here. So the next step is where you're going to, so by the way, I have my B. We can circle that. That's one of the things we need to solve a triangle, right? You need all three sides, all three angles. We have three sides now. So to find my other angle, I'm still missing two angles. So I'm actually going to use the law of sines. So use the law of sines to find, and then it doesn't really matter. So I'm going to find measure of angle A. Am I just like super crooked? So my setup, just as a reminder, my setup would be sine of big A over little a equals sine of big B over little b. And this is why we had to solve for little b first, because that was the only angle I had, so I had to have little b. So then I would have sine of A is over 11 equals sine of 34 degrees over, and then I'm going to put 7.85, and I'm going to show you what happens if you put 7.9, because the answers are like fairly different. So then you get A is equal to, remember the move for this one is you do the sine inverse of 11 times sine of 34 degrees all over 7.85. Are we still good with that? That was from yesterday and the day before. So when you type all that in, you would type 11 times sine of 34, close that parenthesis, divided by 7.85, and you end up with A is approximately 51.6 degrees, which is what your book said, and that's what we're going to circle, and that's all good. What happens though, like if you type in the exact same thing, you do sine inverse of 11 times sine of 34, and then you do divided by 7.9 instead. Look how different the answer is. It's 51.1. That's 0.5 different. Which it's fine. Like I would still say that's a correct answer. But like you could potentially have slightly different, because then it throws off all your answers. Right. So then you're going to get frustrated and go form it, because your next step, how should I find my third side? Yeah, I'm sorry, yes, third angle. Yeah, do the 180. You could do law of sines again, but like why? So just do 180. So you do 180 minus 34 minus, and then we're going to do the 51.6, but you can see if you did 51.1, you have an answer. But you should get that C is approximately 94.4 degrees. So I guess the moral of the story is, please try and save off on rounding until the very end, or round to like the third decimal place for all your calculations, and then at the last step round to the first decimal. Does that make sense? You potentially still could have a couple decimals off on the test. Who cares? I'll figure it out. That's fine. But on Go Formative, I know it's frustrating because you're like, why am I getting the wrong answer? And it could be right. What do we think about law of cosines for side angle side? Not terrible? The rounding is not cool. Yeah. So like I just try not to round until the end and then round. So I honestly, like we could have, I feel like law of sines is just as straightforward as law of cosines is just as easy as law of sines. And law of sines has that weird ambiguous case that does not happen for law of cosines. But since we have to use law of sines with the law of cosines, that's why we had to do law of sines first. Let's look at two more examples. So one more for solving. We have our side case. So we want to solve triangle ABC where A is equal to 12, B is equal to 27, and C is 20. If you wanted to draw a triangle for this, it looks something like this, not a right triangle, but where you have little a is equal to 12, little b is equal to 27, and little c is equal to 20. So I'm not super clear why this is the case, but I think it matters in certain triangles, and I suspect that it has something to do with the ambiguous case from our law of sines. But I guess the book says this kind of just in passing, it just says do this, and it doesn't really tell us why. So your first step here, and we're going to stick with this because I think this has something to do with the ambiguous case. We're going to find the angle opposite the longest side with our law of cosines. Right. Why does that matter? Why should we have to find that biggest angle first? And I suspect that it's because of the ambiguous case. So like no matter what triangle I give you, right, we could have the ambiguous case where there's two triangles that like meet certain requirements, like where they have matching angles and whatever. And so the information that I give you, I could choose to take out some information, and then the triangle is still, so like basically what I'm saying is like maybe I give you all this information, but when you solve for the wrong angle first, I think possibly you can find that other angle from that ambiguous case. And so this just takes care of that, I think. And this is gonna go on YouTube, so I'm probably gonna have comments and that, like, you're an idiot, that's not why. Yeah. I don't know, it's not like a super public video, like, I don't think anyone watches them.
So if the students are watching it.
It's on my old school account.
I mean, like when when we watch the videos, we can't comment from our school account. So we have to like.
Well, that's good, because I might be giving you guys garbage math, but the book says this matters. I looked it up on Google and they sort of were like, this matters, and I'm still unclear why. So we're gonna stick with it and just deal with it. So what we're gonna do is, do you guys remember what's the biggest angle then? If you're given the side, how do you find that? It's always the angle that's across from the biggest side, which would be, I guess, the hypotenuse if this is a right triangle. So it's always, if you guys remember that theorem from geometry, this is the longest side, so the angle across from it is the biggest angle. This is the shortest side, so this should be the smallest angle. You guys remember that a little bit? Coming back. Okay, so that means we're going to solve for little or big B first. So I'm going to use b squared equals a squared plus c squared minus 2 times a times c times cosine b. And I'm just writing this in the notes, but obviously you guys could jump right to the line where you're filling things in. But here's the weird part about this problem. When I fill things in, I have 27 squared equals 12 squared plus 20 squared minus 2 times 12 times 20 times cosine of b. So my variable ends up being over here instead of over here. So the first thing I need to do is I need to rearrange everything so that I have cosine of b equals. So I'm just going to rearrange. I'll have cosine of b equals. And what I would do is I'd take this 27 squared, I'd subtract the 12 squared and the 20 squared. So minus 12 squared minus 20 squared. And then this whole thing, I know it's all being multiplied. It's all being multiplied to the cosine, which means I'm going to divide by -2 times 12 times 20. I'm jumping right to this. Are there any questions about how that works? Sydney looks skeptical, but she's like, all right, I'll buy it. Again, rounding probably matters here, so it's best to just type all this and either use second answer or put this whole thing in. To solve for b, then we would do b is equal to cosine inverse of this nastiness, which if you do all of this stuff, I'll give you the decimal. It would be 27 squared minus 12 squared minus 20 squared divided by -2 times 12 times 20. And so you would end up with this huge decimal, which the book is like, let's just round to the third decimal place. And probably that's fine. Well, so I don't want you to round. The book does. What I suggest you do is if you're going to type it this way, then you do, okay, second cosine and then hit second. And you guys know where your answer thing is? Just use your second answer. Because then the rounding part, like, we don't have to panic about that. So then you get that b is approximately 112.7 degrees. Any questions about that, or did anyone get something different? Do we understand why we did cosine inverse?
That makes a lot of sense.
Okay, so and I really wanted to fit this on 2 pages, but this is a mistake now because now we're going to go over here. Sorry, our step 2 squeezed over here is that we're going to use the law of sines. And technically we could find either A or C. Your book just finds the measure of angle A. Doesn't specify that you have to. So I would do sine A over my A equals sine B over my B. So the setup would be sine of A over 12 equals sine of 112.7 degrees. And I think we're good to leave the rounded one here. That didn't seem to affect anything, or this is how the book does it at least, and how I would do it. So I'll skip all of the calculations, but you would do A equals sine inverse of, and then it'd be 12 times sine 112.7 over 27. And you end up with an A that is approximately 24.2 degrees. And then if you don't want to suffer, you use the rule that these all add up to 180 to find your angle C. So find measure of angle C, and we would do that just by doing 180 minus 112.7 degrees minus 24.2 degrees, and you end up with a C that is approximately 43.1 degrees. And we're putting the degree symbols because remember, Mrs. Hopkins is petty and she takes off points if you don't. What do we think about side, side, side case? Decent. I know these are like a lot of steps, but I think you can have a note card for your test. And you can't have the specific examples, but nothing to stop you from writing the steps. So other than the funny rounding thing, let's make use of our second answer. It's okay. This last one, apparently second hour said they recognized this. Also, I messed up on the notes. Like, I feel like I wrote this heading and then I forgot to erase this from like your last notes. So like, this is all true, but it has nothing to do with what we're doing. So like, cross it off. That was the intro to the ambiguous case from your last section. And I just forgot to delete it. I don't know what I was doing. This crazy formula, which I had never heard of before this morning when I was doing these notes. I've never heard of this. Like, okay, so the Heron formula, I don't know where it comes from.
Lateral triangle, and there was one for the side, side, side.
I literally don't know.
So this is definitely for side, side, side. You have to have all three sides. Because remember, we just found the area when you had what side, angle side. And so this is strictly for side, side, side. And so it's this weird formula where you have area equals the square root of s times s minus a, s minus b, s minus c, where s is 1/2 of your a plus b plus c. So just so you guys know, s is called the semi-perimeter. Or half perimeter of the triangle. So it's super easy to use. Example 3, when we find the area, your first step is to find your semi-perimeter. To find S. So you would just do S equals 1/2 times, and let's say this is my A, my B, and my C, sort of arbitrary. But 1/2, and then it'd be 22 plus 40 plus 6. No, 50. I know how numbers work. And so you end up with an S that's 56. Then your second step is just to use Heron's formula to find area, but write that. So you end up with area equal to the square root of 56 times 56 minus 50 times 56 minus 40 times 56 minus 22. And so your area is approximately 427.5. And then I didn't give you units, but if you had units, it would be units squared, because that's how area works. So this is the area formula when you're given side, side, side. So on the test, if I give you a triangle that's side, 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 or if I give you a side, angle, side, you know which of these two area formulas we've now seen to use. Any questions about this one? Again, super impressed. You all seem to remember this somehow.
This was like the best formula.